Stacks, queues, and decks are all fundamental data structures used in computer science. They store elements in a sequence. Stacks allow elements to be added and deleted from one end. Queues allow elements to be added from one end and deleted from the other. Decks allow elements to be added and deleted from both ends. The stack is a fundamental data structure in computer science. It forms the basis of many applications. The data items in a stack follow a last-in first-out discipline, meaning the item removed is always the last inserted one. An example is a stack of pancakes. You can add a pancake only to the top of the stack. You can only remove the most recently added one from the top. Stacks are used in multiple different applications in computer science. To support function calls, stacks are frequently used in programming languages. Arithmetic expressions are evaluated using stacks. Stacks can be used to implement undo and redo actions, which are features offered by many programs like editors. Stacks are used by web browsers to keep track of browsing history. Stacks are used by a number of algorithms, including depth-first search and backtracking, to maintain or track the problem states or decisions taken. Stacks can be used to verify that the expression's opening and closing parentheses are matched. Stacks are also fundamental to the creation of compilers and interpreters. The stack supports the push, pop is empty, top of stack and size operations. The operation pushX adds X to the top of the stack. The operation pop removes an item from the top of the stack. The operation isEmpty returns true if the stack is empty. Otherwise, it returns false. The operation top of stack returns the value of the top of stack element without removing it from the stack. The operation size returns the number of elements currently in the stack. An implementation of the stack data structure using Python lists is shown here. Like the stack, the queue is another fundamental data structure in computer science. The queue supports a first-in first-out discipline. Items are added to the rear of the queue and removed from the front. The queue data structure has several applications in various domains. Queues, for instance, are often used in job scheduling systems. In print spooling systems, print requests are added to a queue and processed in the order they were received. For process synchronization in message passing systems, a queue is used to hold messages sent between processes, ensuring first-in first-out order, that is, messages are delivered in the order they were sent. Breadth-first search in graphs uses a queue to keep track of the vertices that need to be visited. Queues are also used as buffering, to hold data arriving at a rate faster than the rate at which it is consumed. Queues are used in traffic simulators. For instance, flights waiting for approval from air traffic control for departure from a runway at an airport can be represented using a queue. In web servers, queues are often used to handle incoming requests. The queue data structure supports the enqueue, dequeue, size, and isEmpty operations. The enqueue operation adds an element to the end of the queue. The dequeue operation removes the element at the head of the queue. The size operation returns the current size of the queue. The isEmpty operation returns true if the queue is empty, and returns false otherwise. An implementation of the queue data structure using Python lists is shown here. The deck is a double-ended queue which supports both LIFO and FIFO paradigms. That is, elements may be added to the front or the end of the queue. Elements may be deleted from the front or the end of the queue. Decks provide all the capabilities of stacks and queues in a single data structure. The deck is a natural choice in some problems like palindrome checking. It is also used in certain job scheduling and sliding window algorithms, requiring addition and deletion of elements at both ends of the queue. Deck operations include add first and add last, which involve adding an element to the front and rear of the queue respectively. Deck operations include remove first and remove last, which involve removing an element from the front and rear of the queue respectively. The size function returns the size of the deck. IsEmpty returns true if the deck is empty. Otherwise, it returns false. An implementation of the deck data structure using Python lists is shown here. A question. What does the given sequence of statements print? Assume printDec prints the deck in order from the first element to the last element. The state of the deck after each operation is shown. The first printDec statement prints -26, 15, 5, and -16. The next printDec statement prints -26, 15, 5. The last printDec statement prints 15, 5. Thank you. This course is brought to you by Elahey Technologies.